This is Mrs. Wainwright's Math Class, Chapter 1, Lesson 1F, Place Value and Patterns in Various Formats. Today's learning target: by the end of today's lesson, you should confidently be able to say, I can describe the relationship between two place value positions. Sometimes you won't see a problem that looks as simple as 785 times 10. Instead, it will say, blank is 10 times as much as 785. It's worded differently, but it means the same thing. And if we look back at it, it really is saying 10 times 785. So you can solve it the same way. So let's go over this. 10 times means I'm multiplying by 10. That's my base 10 or my power of 10 number because it has a 1 and zeros. And that 10 is greater than 1. Greater has the R's, which means I'm going to be moving my decimal to the right. How many places? Look at the number of zeros. I have 1 0, so I'll be moving my decimal 1 place to the right. My starting number is 785. I'll rewrite that. I'll put in the decimal by removing the invisibility cloak. Cross out the decimal, move it 1 place to the right. There's no digit to move it around, so of course I'm going to add a place value 0. Now I can move it around that digit 1 place, and that's my new decimal. So my answer is 7850. I can choose to put that decimal at the end or not, since it's the last thing that I see as the decimal. This is more than 3 digits in my whole number column, so I'll count backward. 1, 2, 3, put my comma. So my answer is 7,850. Let's go ahead and move that up onto my answer line, 7,850. And the quick double check that I should ask myself every time I'm finished solving a problem is, does this answer make sense? Does it make sense that 7,850 is 10 times as much as 785? And yes, it does make sense, because 7,850 is larger than 785. It's 785 times 10. So the answer is yes, this does make sense. So let's take a look at another example. We'll call this one example number 1. Blank is 10 times as much as 2,000. Okay, I know it's asking for 10 times as much. I know that would be my power of 10 number because it has a 1 and zeros. So I say to myself, is 10 greater than 1 or less than 1? 10 is greater than 1, which means I'll be moving to the right. Greater has the R's, moving to the right. How many places? Well, there's 1 0, so I'll move it to the right 1 place. Take my given number that is not the power of 10 number, 2,000. I'm going to rewrite that number. And I know I have to move my decimal to the right 1 place. I don't see a decimal, so I simply remove the invisibility cloak. My decimal is at the end. Cross out the decimal. Oh, can't move it to the right. So of course I add my place value 0. Now I can move my decimal 1 place, put it back in. So now I'm going to write my answer right on my line, my 2, 0, 0, 0, 0. I'm choosing not to put the decimal at the end. I could if I want to, but I'm choosing not to. But I do say that I have more than 3 digits in my whole number column, so I'll count backwards for my commas. 1, 2, 3, comma, 1, 2. Good. So again, my question is, does it make sense? Does it make sense that 20,000 is 10 times as much as 2,000? Yes, because 20,000 is 10 times 2,000. It's greater than 2,000. So yes, my answer does make sense. Stop the video and do worksheet number 1 right now. Remember, you can go back to this problem slowly, step by step, to help you complete worksheet number 1. Now we'll move on to example number 2. Sometimes you'll see a problem and the power of 10 number will be first. Here I have 100 times 70 equals blank. Both numbers have zeros, so how do I know which is the power of 10 number? Remember, the power of 10 number is the number with a 1 and zeros. So could it be 100? Yes, that's a 1 and zeros. Could it be a 70? No, because that's a 7 and zeros, and I need it to be a 1 and zeros. So my 100 is a 1 and zeros. Therefore, this is the number that will help me decide how to move my decimal. Well, is 100 greater than 1 or less than 1? 100 is greater than 1. My R's tell me I'll be moving my decimal to the right. How many places? Count my zeros. There are 2 zeros, which means I'm going to move my decimal 2 places to the right. So I'm going to go ahead and take my other number, which is a 70. I'll rewrite it, remove the invisibility cloak to find the decimal. I know I have to move that decimal 2 places to the right. Cross out the decimal, add a place value 0, another place value 0, and now I can move it 2 places to the right, put my new decimal back in. So I'll transfer that answer right to my answer line. That's a 7, 0, 0, 0. This time I feel like putting the decimal at the end because I can if I wish to. I do see that my whole number is more than 3 digits, so I have to count for my commas. 1, 2, 3, comma. So 100 times 70 equals 7,000. And again, when I finish the problem, I always stop and ask myself the question, does it make sense? 100 times the number 70 would be 70,000. That means I have 70 100 times. Yes, that does make sense that my answer would be 7,000. I'm multiplying by a number greater than 1, so my answer is greater than the 70 I started with. 100 times the 70 is 7,000, so I'm happy with my answer. Now please stop the video and complete worksheet number 2. Let's take a look at problem number 3. I have 0 and 1,000th times 30. Which number is the number that will tell me what to do with my decimal? It's going to be my first number. 0 and 1,000th is a 1 with zeros. So this is my power of 10 number. What does this number tell me for moving my decimals? Well, 0 and 1,000th is less than 1. Less has an L, so I'll move my decimal to the left. How many places? Count my zeros. 1, 2, 3. I'll move my decimal to the left 3 places. Take my other number, which is my 30, rewrite it, remove the invisibility cloak if necessary. In this case it is. Cross out my decimal. I want to move it to the left 3 places. So there's 1, 2. Uh-oh, I don't have a digit to move it around. Well, we know that's a simple solution. Add in a place value 0. Now I have the 3rd place to move it around, and there's my decimal. I'll rewrite my answer on the line. Decimal 0, 3, 0. Remember, although you will see it that way sometimes, it is best if there are no whole numbers to put a 0 in that one column just to make it stand out even more that there are no whole numbers, and this is totally a fraction number or part of a whole. So as written, my answer is 0 and 30 thousandths. I could also write 0 and 3 hundredths, as those numbers are equivalent. Notice on the purple line in my 0 and 30 thousandths, this is a decimal number, and the ending 0 in a decimal number is an unnecessary 0. So you can drop the unnecessary zeros if you wish. Now I'm going to ask myself again the oh so important question, does it make sense? So my starting number was 30. I have 30 whole chocolate bars. I'm going to multiply that by 1,000th. So I'm going to take each chocolate bar, break it into 1,000 pieces. I'll have one of those thousandth pieces from each chocolate bar. So I'll have 30 thousandths. And my answer is 0 and 30 thousandths. So yes, This does make sense. Please stop and complete worksheet number 3 right now. Example number 4, sometimes you'll see a problem with a fraction that may look like this. 800 times 1/10. Listen to that, times 1/10. Well, that 1/10 as a fraction is the same as writing it as a decimal this way. It's the same as 0.1. 1/10 as a fraction, 1/10 as a decimal. I'm still multiplying that 800 by 1/10, so I follow the same format. When I look at that fraction 1/10, how do I know that that's a power of 10? How do I know that that's the number that helps me decide what to do with my fraction? Well, if it's a fraction, my numerator must be 1, and my denominator would be a 1 with zeros. So it could be 1, 10, 100, 1,000, 10,000, etc. My denominator is a 1 with zeros. If my numerator is 1 and my denominator is 1 with zeros, that's my base 10 number. It's the power of 10, and it helps me to decide which direction and how many places to move my decimal. So let's go ahead and solve it. Again, my 1/10 is my power of 10 number. 1/10 is definitely less than 1. Less L means left. How many places? Well, there's 1 0, so I'm going to move it 1 place to the left. Take my given number, 800, rewrite it. I have to remove the invisibility cloak to show my decimal. Cross out my decimal, and I'll move it 1 place to the left. So I'll rewrite my final answer, 80.0, or I could also say 80, because that ending 0 in a decimal column, right, it comes to the right of the decimal, it's after the decimal, it's an ending 0, that is an unnecessary 0, so it can be dropped if I like. Now the question, does it make sense? 800 times 1/10. That means I have 800 Hershey bars. I break each Hershey bar into 10 pieces, and I have 1 piece from each of those Hershey bars. So will I have 80 pieces? Yes, I will. So 800 times 1/10 equals 80, and 80 is less than the 800 I started with. Yes, it makes sense. Stop and complete worksheet number 4. And again, in the various ways we see the problems, example number 5, sometimes a problem will be worded this way. Blank is 1/10 of 672. I know that my 1/10 is my base 10 number. It's a fraction that has a 1 as the numerator. My denominator is a 1 with zeros. Something that you may not know, but you'll be using from 5th grade on, is that when working with fractions and decimals, of means times. So I am working with a fraction here, 1/10, and if of means times, then right above that of sign, I can put a multiplication sign. So let's go ahead and solve this problem. My 1/10 is less than 1. L for less means I move my decimal to the left 1 place, because there's 1 0 in the 10. 672 is my number that I'm going to rewrite. Remove the invisibility cloak. I'll cross out that decimal, and I'll go ahead and move it 1 place to the left. Copy my final answer onto the line, 67.2. And of course, at that end of problem question, does it make sense? 67 2/10 is 1/10 of 672. My starting number was 672. I multiply it by 1/10, which is less than 1. So my actual answer of 67 2/10 is less than the number I started with. Therefore, yes, this does make sense. Please stop and complete worksheet number 5. And let's review. When multiplying by power of 10 numbers that are greater than 1, which could be 10, 100, 1,000, 10,000, we can see it in the following formats. I might see 45 times 10 equals blank, or it might be flipped around and say 10 times 45 equals blank, or it might say blank is 10 times 45. Either way, all three problems get solved in the same format. My 10 is my power of 10 number because it has a 1 and zeros, and I know that 10 is greater than 1. Greater has an R, which means my decimal moves to the right. It has 1 0, so my decimal will move to the right one place. Take my 45, remove the invisibility cloak, cross out the decimal. I'm going to move it to the right one place, so I need to add one place value 0. Now I can move it one place and put the decimal in, which means that my final answer would be 450. 45 times 10 is 450, 10 times 45 is 450, and 450 is 10 times 45. And in my check, I multiplied by a number greater than 1 because 10 is greater than 1. So my answer, 450, is greater than the original number or the original 45 I started with. Therefore, that makes sense. The next part of review is multiplying by a number that was less than 1. Powers of 10 that are less than 1 would be 1/10th, 1/100th, 1,000th, or 1/10,000th, and they would be written in either decimal or fraction form. Here's one type of problem we could see for a power of 10 number that's less than 1. This would be in this would be in decimal format, 45 and 1 times 0 and 1/10. Sorry, I'll say that again. 45 times 0 and 1/10 equals blank. Here's another way that you might see this problem. You may see it in fraction form. 45 times 1/10 equals blank. Or the base 10 number may come first. Here we see it in decimal form. 0 and 1/10 times 45 equals blank. Or the fraction form, 1/10 times 45 equals blank. Finally, you may also see it in the sentence format, which looks like this. Blank is 1/10 of 45. And remember, when working with decimals or fractions, of means times. Although they look different, all of these are the exact same problems, so let's go ahead and solve. Whether it's written in decimal or a fraction, 1/10 is less than 1. Less means I move to the left one place because there is 1 0 there. Take my other number, which is 45. Remove the invisibility cloak. I'm going to cross out that decimal and move it one place to the left. Put that decimal back in. My final answer is 4.5, or 4 5/10. 45 times 1/10 is 4 5/10. 1/10 times 45 is 4 5/10. Again, fraction form, 1/10 times 45 is 4 5/10. And finally, 4 5/10 is 1/10 of 45. And does it make sense? Well, I multiplied by a number less than 1, so my product or answer should be less than the number I started with. In this problem, I started with 45. And my product or answer, 4 5/10, is less than the 45 I started with, so yes, this makes sense.